Hello, hello. These are the notes for polynomial factoring. So you've probably done factoring before. We've done it where, you break it up into two parts, or maybe you take a number out like GCF. Um, you've done sum and difference of squares, sum and difference of cubes. Not sum of squares, that's not a thing. Difference of squares or sum or difference of cubes. So we're going to put it all together today. And what we are going to make sure that we do is focus on this first thing. The number one rule of factoring is that before anything is done to the polynomial, the terms must be ordered from greatest to least degree. So what I mean by that is if you have like x squared and x third and x to the fifth, you want to put the x to the fifth in the front and then the x to the third and then the x squared and then x or a number if you have it. Beyond that, there is a series of things to check for to break the polynomials down into prime factors. So the first thing that we're going to do is put them in order. So I'm going to call that like step 0. So put in order. All right, so step 0, put it in order. Okay. Assuming that they're now in order, we're going to look for a GCF. GCF is like taking out a number or taking out a negative if it's in the front. That will just make our problem a lot easier to solve. So that's like when we see like, okay, everything has -2 in it, and then we take out everything else, leave it in there. So we'll start. So then the second step, the second thing that you can look for after you put it in order and GCF as much as possible, then we can look for a variety of things. So the difference of squares, if you need a reminder, there's a video there. Difference of squares, remember, is like when you have x squared minus 16 and you recognize, oh, okay, x squared is a square and 16 is a square. So this could be x plus 4, x minus 4, like that. So that's like a very common example. So I'm going to go ahead and try this problem here. I'm going to check that it's in order, which it is, x to the third and x. They're in decreasing degree. And then I'm going to look for a GCF. So I see they both have x in common, so I know I'm going to take that out. And then 2 and 32 can both be divided by 2. So I'm going to go ahead and take a 2 out. So then what would be left if I divide out that 2x is I would have x squared minus sign, and then 32 divided by 2 would be 16. X divided by x would be 1. So there we have it. And actually, this is the same as our example. So x squared is broken into x and x. 16 is broken into 4 and 4. We have one positive, one negative. In order to, when they multiply together, they have to be that negative. We still have the 2x out front, right? Remember, if you need a reminder on like how this works, x plus 4, x minus 4 would make x squared, positive 4x, negative 4x, and negative 16. And those x's would cancel, right, and leave us just with that x squared minus 16. So that's how it multiplies back together to get there. And then we would multiply in that 2x. So this is our factored version. Has everything broken down into its smallest pieces, has 3 pieces here. It has 2x, it has x plus 4, it has x minus 4. I want you to go ahead and try to work on this next one. So press pause on the video, work on this one, and come back. Assuming you're back, I'm going to show you how to do this one. So we want to put it in order, step 0. So -3x to the third plus 12x, because x to the third is the biggest degree, the largest degree. So then I'm going to try to take out anything that I can, including that negative, because that negative is annoying to me. So I'm going to take out the negative. I'm also going to take out 3, because both 3 and 12 are divisible by 3. And I also see that they have an x in common, so I'm going to take that out. That's going to leave me with just x squared here, which is great. Positive divided by a negative would mean that I have a negative left in here, because the negative and a negative have to make that positive. And then I have 4 here, which is great because this is now the difference of squares. Remember, it has to be subtraction. So this would be x plus 2, x minus 2. We're breaking this into these 2 pieces. And then we're going to bring down the -3x. And that would be our answer. If you'd like to take another look, you can try to do this one. And then if you scroll down to the bottom, you'll see the answer. So you can try that one. I'm just going to do 2 for the video. So The next thing that it might be, so if we look at it and we're, okay, this is the difference of squares. So we're like, okay, great, difference of squares. But if we look at this one, these are not squares, these are each cubes, right? Because this would be like x to the third minus, and then 27 is 3 to the third. So this is the difference, because it's subtraction, of 2 cubes. And remember from algebra 2 that there is a formula for the difference or sum of cubes, which is where we have like a, b, a squared, ab, and b squared. I call it the ombre formula because we're saying like it's going from a to b, starting with a lot of a, then a mixture of a and b, and then a lot of b, right? So if you think about it like hair, you have like, maybe you have blonde tips, right? So you start with like dark, and then in the middle it's like dark and light, and then at the bottom it's like all light, all blonde. So that's like the setup. And then there's SOAP to tell you what signs to use. So it's same as the problem, opposite of the problem, and then always positive. That's how I remember the signs. So in this problem, we have subtraction, right? So the first sign is going to be subtraction because it's the same. And then opposite would be the next sign, so plus. And then the last one is always positive like that. Okay, so I'm going to use that formula in order to help me factor this part. So I know this is x to the third, and this is 3 to the third, like that. So x and 3 are going to be my a and b. So I'm going to have x minus 3, and then I'm going to have x squared plus x times 3, that's the ab part, plus 3 squared, right? Because that's b squared. So I just need to quickly simplify here. I'm going to have x minus 3, and then x squared plus x times 3 is 3x plus 9, like that. For the difference or sum of cubes, it's always going to be like one linear term at the beginning and then a quadratic term at the end there. So always going to look like that at the end when you're done. Yes. So you can pause here. I'm going to start this one for us. I'm going to help us do the GCF, and then I will, you can pause it. So let's say we're doing this one. I see a GCF. I know I can take an x out of both. I know I can take a 2 out of both. So I'm going to start with that 2x on the front there. That's going to cancel here and leave me with x to the third plus 8, and the x's cancel. So I have 2x at the beginning, and then I have x to the third plus 8. And I recognize that 8 is a cube as well as x cubed is a cube. So this is the sum, because we're adding the sum of cubes. So I'm going to use the same formula, but instead of the minus first, I'm going to have a, b, a squared, ab, b squared, like that. But I'm going to have same, so positive, opposite, negative. The last one's always positive. Same, opposite, always positive. So in this case, I can sort of think of this as like x to the third plus, how do we make 8 into a cube? That'd be 2. So 2 cubed, like that. So this a is going to be x, and b is 2. So I won't write them on top, I'll write them underneath. X plus 2, x squared minus, you can imagine 2 times x would just be 2x plus, and then 2 squared would be 4. Like that. Don't forget to bring down the 2x from the beginning, right? That 2x, since we factored it out, will always be there. So you can have this as your answer here. Okay. I know this one looks complicated. We're just refreshing our brain. If you need additional refresher, there's another video here. If you want to try one on your own, you can do this problem and then scroll down to the bottom, and you will see that problem is worked out at the bottom there. So if we have 2 terms, so far we've only looked at problems that have 2 terms. It could be the difference of squares, or it could be the sum of cubes or difference of cubes, right? Those go together, the same. Or it might just be 2 terms, right? If it's just 2 terms, you just leave them. If they're not squares or cubes, you can't do anything with them. So if there are 2 terms, you're going to be looking at this, right? But we also might have a situation where there are 3 terms. So you can see 1, 2, 3 terms. And this is the quadratic form. You might remember it being like the X factor. You might remember like guess and check, but you know it's going to break into 2 basic groups here, right? So the way that that I would recommend doing this is with the X factor. So you know that some numbers are going to need to multiply to get some number and add to get the middle term. So since we have, oh, first let's check for a GCF. I have no x's in the last one in 20. There's nothing there, so I can't take anything out. And 2 and 13 and 20 don't have any numbers in common in terms of like divisibility. And so there's no GCF. So I'm done with the GCF. I'm going to do 2 times 20. That's going to be 40. And then negative 13. So I need 2 numbers that multiply to get 40 and add to get negative 13. I know they're both going to be negative since they multiply to get a positive number. And then I'm thinking of 13. I know 13 is like 6 and 7, but that would make 42. I know it's 8 and 5. That makes 13. 8 times 5 is 40. So negative 8 and negative 5. Okay. Since I multiply times 2, I also have to divide that 2 back out. Right? So in this term here, that's going to give me negative 4. And this term does not simplify. So I would have x minus 4 and x minus 5 halves. I don't want to have 5 halves there, so I'm going to take this 2 and move it out front here. So I have 2x minus 5 and x minus 4. That would be how we would do it when there are 3 terms. That's quadratic form. The one thing I want us to like be careful of here is that there is a 4 power here, which means I need these 2 x's to be x squareds instead of just x's, right? The reason that I need it to be that is because I need x squared times x squared to make x to the 4th, just like x times x gives me x squared, okay? So I'm going to look at these. I'm going to double check them because now they're in 2 terms. So I want to see if either of them is like the difference of squares or the difference of cubes. I see that x squared and 4, those are both squares. So I'm going to go ahead and do x plus 2, x minus 2. So I can break that yellow one into these 2 pieces here. And then 2 and 5 don't have anything in common, no GCF. And 5 is not a square, nor is 2. So we're just going to leave 2x squared minus 5 here. 2x squared minus 5 here. That is probably one of the most complicated ones you'll see all day. So we'll do another one just so we can see. So in this problem here, we have x to the 4th, x squared, and 5, which you recognize is like pretty much the same as solving for this, right? We're just going to put x squareds in each of them at the same time. So I need 2 numbers that multiply to get negative 5 and add to get 4. Right, so multiply to get negative 5, add to get 4. So negative 5, all it is 5 and 1. And I need to get positive 4, so I'm going to subtract 1. So 5 minus 1 would be 4. So I would have here, I'd have x plus 5, x minus 1. That would be like normal factoring, x factoring. But since it's x to the 4th and x squared here, we want squareds there, right? That if we multiply them back together, we get x to the 4th. And we're just going to double check if we have any difference of squares or difference of cubes. It's probably way more likely to have difference of squares. 5 is not a square, so that one is not doing anything. 1 is a squared, 1 times 1, and it is subtraction here. So we would have x plus 1, x minus 1. We can split this one into 2 groups here, positive and negative. And then that would be our answer. If you want to try one on your own, you can go ahead and try this one. Don't forget to take a GCF out. I already see that I can take out 2 from each of these. I can also take out x from each of these. So factor out that 2x first, and then you can see the answer at the bottom. Okay. All right. Finally, we have our last one, which is factoring by grouping. This is when you have 4 terms, right? 4 terms or 6 or 8 or 10, those are less likely. 4 terms is more common. So when you have 2 terms, just for a refresh, 2 terms, look for difference of squares or sum or difference of cubes. If you have 3 terms, look to see if it's in quadratic format. So it could be in like x squared plus x plus a number, or it could be x to the 4th plus x squared plus a number, or I mean, technically it could be x to the 6th plus x to the 3rd plus a number. We're not quite there yet, but you could do it there. You could do many multiples of that if you would like. And then if you have 4 terms, like 1, 2, 3, 4, then you can use factoring by grouping. So factoring by grouping here, I'm going to go ahead and group these together and group those together. I'm going to use a different color. It's blue. So I want to know, I'm going to factor the GCF out of each pair. So out of the pink group, I can see that both have an x and x squared in common. But that's pretty much it. So I'm going to have x squared is coming out to the outside. And that's going to leave me with 2x, positive sign, and 3, like that. And then for the blue one, I see that both of these can be divisible by -4. So I'm going to take out a -4. And then I have left over 2x plus 3. -12 divided by 4. -4 is positive 3. What is really, really, really important here is that the leftovers, right? The leftovers have to be the same. Otherwise, this doesn't work. So the leftovers have to be the same, because what we're doing is we're taking, actually, since the leftovers are the same, what we can say is we're actually factoring out 2x plus 3 from the whole thing, from all 4 items. We're taking out 2x plus 3. So we would have 2x plus 3. We're taking it out from the pink and taking it out from the blue. We're taking it out from everything. And then what's left over are the x squared and the -4, right? So the x squared is coming out and the -4 is coming out. Those are our leftovers, technically, because we didn't take them out of both, right? So we took out x plus 3 out of all 4. 2x plus 3 came out. And then left over, when we take that out, when we divide that out, we have x squared -4 left over. As you might be remembering, x squared -4 is a difference of squares. So we're going to break that into x plus 2, x minus 2, and we're going to be left with 2x plus 3. Right? That is going to be our answer altogether. Okay. Go ahead and pause the video and try this next one. And then I'll come back. Pausing. Cool, and we're back. So I'm gonna start again. I have pink and I have blue. So what's in common out of the pink one? I can see x squared. So taking x squared out of each of these leaves me with 2x plus 1, right? Because x squared divided by x squared is just positive 1. And then out of 18 and 9, I can get 9, and I want to take out that negative. So taking out the negative, so I again have 2x plus 1, which is good that those are the same. That means I can take it out of all 4 altogether. So I would have 2x plus 1 is the beginning, and then the x squared and the 9 would be what's left over, x squared minus 9. Notice difference of squares, don't forget, keep going, is I would have x plus 3, x minus 3, not 2, and 2x plus 1, just like that. Fix that 3. So that would be my final answer there. If you want to try one more, you can go ahead and try that one there, and the answer is at the bottom here. If you were confused on any of these, all of the answers are here written out, so you can go ahead and check them out there. Or I have office hours today. Drop by, ask a question. I will talk to you guys soon. Thanks, y'all.